All right, guys, part 2 of arithmetic and geometric sequences. I have up here some pieces of information about an arithmetic sequence. I'm using a sub whatever number we're talking about here and here to just show that this is an arithmetic sequence. So here all we're given is the fourth term. We're told the fourth term in the sequence is 9, and that the common difference is -3, and we're asked to find the 20th term. So what we want to do in a question like this is we want to start by coming up with a formula for the nth term. So for all arithmetic sequences, we learned in the last video that the nth term is equal to whatever term we choose plus d multiplied by n minus k. All right, so because we're given the fourth term, this is what we're going to use for a sub k. We're going to plug in that 9, and then that means k is going to be just 4 for this one. All right, so a sub n is going to equal a sub 4, which is 9, plus d, but we're told that d is -3, or you can make it a -3. And then we've got our n minus k. K, we went with the fourth term, so k is just 4. Now be careful, you can't subtract the 3 from the 9 because the 3 is being multiplied here. What we are going to do is plug in that 20, though, for n. And so that'll give us the 20th term if we just plug that number in and then solve. So order of operations, I would subtract first in the parentheses to get 16, and then I would multiply with that -3. So this is not minus. So we're going to have to do 3 times 16, so that's 48. And then if we subtract these, that would give us -39. All right, so that's our 20th term. And again, we could double check by listing out all 20 terms, but that might take a little longer than we want to put into this question here. All right, next example. Now we're given not the difference, we're given the second term and the sixth term. All right, so we have a sequence. We don't know the first term. We know the second term, a sub 2, is 1. We don't know the third term or the fourth term or the fifth term, but we know the sixth term here is 11, okay? Also, because we're using a's, this is arithmetic, so we know that the formula is the same as the last problem. So a sub n equals a sub k plus the common difference times n minus k. All right, so in this question, we're going to have to figure out what d is, and it's not always the easiest to find, depending on if we have decimals or fractions, positives and negatives. So sometimes you can just kind of see, oh, we're adding this number over and over, but sometimes it may not be that easy. So here's what we're going to do. We're going to come up with an equation that helps us to solve for d first. All right, so we're starting at 1, so we would have to add the common difference 1, 2, 3, 4 times. All right, we'd have to add d 4 times to get from the second term to the sixth term. So the way we can write an equation, well, we're starting at 1, and we're adding d 4 times. So instead of writing plus d 4 times, I'm going to write plus 4 times d, and that should give us the number 11. So now we have an equation we can solve for d, and then we can go over here and use that formula once we know what d is. So if I subtract 1 from both sides, that's going to give us 10. And then if I divide both sides by 4, we get 10 fourths, which if we divide those both by 2, we get 5 halves. All right, so that wouldn't be the easiest to figure out, that we're just adding 2.5 each time, or 5 halves. All right, so d, that's what d is. And so now we know our formula. If we want the nth term, we could start with any term. I could start with the second term, which is 1, or the sixth term, which is 11. I'm going to use the sixth term here, but again, both are fine. So let's see, the sixth term is 11, so a sub k is 11. We just figured out that d is 2.5, or 5 halves. And then k, because I went with the sixth term, k is going to be 6. All right, if we want the 30th term, we're just going to replace both of the n's with 30s here. So put a 30 there and a 30 here. And now again, order of operations, we're going to subtract do what's in the parentheses first, which is subtraction. So that gives us a 24. Now, multiplying this fraction with a whole number, I like to see if anything simplifies first because we have a divided by 2, and this is also divisible by 2. So what we could do is go ahead and just divide that 24 by 2. It's going to turn this into a 5 if we do that, and this into a 12. All right, so that makes the numbers a little bit more manageable. Again, because I was dividing by 2, it doesn't matter if I divide the 5 by 2 or the 24. I just divided the 24 by 2 instead of the 5. All right, now we can multiply. And so that gives us 60, and then we add 11, and we get 71. All right, so that would be the 30th term of that sequence. Now, same idea, but we have a geometric sequence, and we're just going to come up with the formula for the geometric sequence. We're not going to use it to evaluate on this one. All right, so our equation for g sub n is always g sub k times r to the n minus k. All right, so we have 2 terms. We don't know what r is, though. And so same idea. If we start with the second term, which is 2, we don't know the third term. We don't know the fourth term, but we know the fifth term, g sub 5, is that 27 over 4. Now, with geometric functions, we are multiplying. So arithmetic, we're adding or subtracting. Geometric is always multiplying. So we know that we have to multiply by r on this problem, times r, times r, times r. To get from the second term to the fifth term, we're going to multiply by r 3 times. So again, we're looking for an equation that helps us to figure out what r is. So we're going to start off by writing the first term. And then because it was times r, we're going to do times r times r times r is really r cubed equals the last term. All right, so this is different from the last one. The last one we were adding d 4 times, so it was the first number plus our 4 differences equals the last number. And then now that we're multiplying, it's the first number times r 3 times, or times r cubed equals the last number. So to solve this for r, it's a little complicated. What we're going to do is move the 2 over first. And you can do that by dividing by 2, but then you have 2 fractions within a fraction. So the same thing as dividing by 2 is multiplying both sides by a half. We'll multiply both sides by 1/2 here. All right, so those 2's cancel. The left-hand side is now just r cubed. The right-hand side, we get 27 on top. We get 8 on the bottom. Then to get r by itself, we want to get rid of the cube. So we're going to cube root both parts of our fraction here. The cube root of 27 would just give us 3, because 3 to the third is 27. And the cube root of 8 would give us 2, because 2 cubed is 8. All right, so that's what r is, 3 over 2. And I know that is complicated, yes. But we're gonna do our best on it and hope we can figure out what r is. All right, so r is 3 over 2. So now our formula says g over n equals, I'm going to leave that blank for a second. R is going to be 3/2 to the n minus k. So g sub k, we could get from the problem. It could either be the second term or the fifth term. I'll go with the second term this time. So the second term is 2. So I'm going to put that 2 right here. And then because I'm using the second term, k is just going to be 2. All right, so this is our formula. And then obviously if the problem asked us to find like the 8th term or something like that, I would plug in an 8, subtract, and then we'd have to do that to the 6 if we were subtracting 8 and 2. All right. So I think, was that the last one? That was the last one. That's calculus after that. All right, so that's it for this video, guys. Stay flawless.